Hi guys, welcome to our channel of Sciences and Mathematics. Our topic for discussion for today is going to be maybe a complementary discussion on what we have discussed on trigonometry. We're going to look at the basic trigonometric functions and some of the areas like the relationships between trigonometric functions and their inverses. So in this case also we're going to have a sample question at the end of our discussion to try and see what are some of areas in which the trigonometric functions can be applicable. So without further ado, thank you and welcome. So today we're going to look at basic trigonometric functions. And these are going to give us a basis on how to try and do an application for one or two of these relationships that we're going to learn. So in our previous video, we had talked about the concept of a right triangle. And I'm going to draw an illustration here so that we can be able to catch up from there. So this is a three-sided figure. Draw a larger one. So this is a three-sided figure that has got, just note it using that. Okay. X, Y. We talked about a rectangular coordinate system, so this is the X and Y. And then we have point X at this point and P. So there's a difference between this and this. So this capital X, this X. So this one refers to that distance, and there's an angle measure for theta at that particular point. And there are specific terms that we're going to use for these three different sides for the triangle. Let's call this one I. When we were trying to draw a circle, we said that the distance between the origin and point P, if it circumscribes, we're going to form a radius. But in this case, we're just going to use the letter R to denote the distance between the origin O and point P. So therefore, for a right angled triangle, X is referred to as the adjacent with respect to this angle. Y is referred to as the opposite. So it is opposite with respect to angle theta. And then we have R is referred to as the hypotenuse. Now in this case, we're going to see that the trigonometric functions that we talked about, which are the identities, which are basically the relationship which exists between these three sides of a right triangle, are going to be given as the sine, the cosine, or maybe let me just give it the sine, the cosine, and the tangent, which are given by the initials or maybe the acronyms for sine, the cosine, and the tan. Now this one refers to the tan of this angle. So therefore, for the tan of theta, the cosine of theta, and the sine of theta are given as such. These are relationships that describe the ratio between the distance, which is y over r, which is y over r. So therefore, opposite the angle, hypotenuse, and this is adjacent. So basically, we can say that sine is the relationship between opposite over the hypotenuse. So this is opposite over the hypotenuse. And then cosine is given as x over r, which basically adjacent over the hypotenuse. Adjacent over the hypotenuse. And theta, the tan of theta is given as y over x, which basically is opposite over the adjacent. So if we try to look at the relationship that I've listed on the board, we're going to see that one of them is a derivative of the other, in a sense that if we write tan of theta, which is equivalent to 1 over x, this one can be achieved if we try to write this is a y over r times r over x. So this ratio y over x can be achieved by the product of y over r times r over x, which stems from the fact that we can be able to write y over r as the sine of theta, whereas r over x, this is x over r. R over x is going to be the inverse of the cosine of theta, so therefore 1 over the cosine of theta. So therefore this is going to give us a product of a ratio of the sine of theta over the cosine of theta, implying tan of theta is equals the cosine of theta over the sine of theta. So the third one is a ratio between the two trigonometric ratios that we have given. So there's generally a term that we're going to use referring to these specific derivatives from these other angles, and we're going to see that one when we're going to discuss about the inverse of angles. So for that case, I'll just do away with this one, and we'll just have a look at the relationship that exists between these specific ratios that I've talked about. So if I still repeat our figure here, x, y, r, theta, O, x, p, from Pythagoras theorem, these three sides of the three sides of a right triangle can be given a relationship whereby r squared, which is hypotenuse squared, is the same as adjacent squared plus opposite squared. So this relationship exists whereby therefore we can just give one side like r is equals the root over x plus y square, the square of those two. So in this case, this is a relationship that exists between the three sides of this right triangle, and they can be given using Pythagoras theorem. Now we're going to see that the concept of inverse trigonometric functions, just an inverse of the basic trigonometric functions that we have listed. So an inverse can roughly mean opposite, but for this case we're going to see that there's a relationship. We can give an acronym for the relationship that we have found for the three trigonometric ratios, in that this sine of theta is given as opposite over hypotenuse, whereby O implies opposite and h hypotenuse respectively. Or the cosine of theta can be given as adjacent over the hypotenuse, where C represents the cosine adjacent hypotenuse, and the tan of theta can be given as opposite over adjacent, where T represents the tan opposite and adjacent. So this acronym is SOHCAHTOA, which is going to assist us to remember the three trigonometric ratios that we have mentioned. Now in this case we're going to have the inverses, which are going to be given as 1 over the sine of theta. The second one for cosine is going to be given as 1 over the cosine of theta. These are the inverses. And then the last one is going to be given as 1 over the tan of theta. Now for the three ratios that we have talked about, the inverse can be given as such, and there are specific terms that we use to refer to these three inverses of the basic trigonometric identities that we have, the trigonometric functions that we've talked about. And the first one, for the inverse of sine, we refer it to as cosec of theta. So therefore 1 over sine theta is equivalent to cosec of theta. And then for the second one, 1 over the cosine is referred to as the sec of theta, and then 1 over the tan is referred to the cot of theta. So whenever someone mentioned the cot of theta, it refers to 1 over the tan of that sec, 1 over the cosine, and etc. Now, the relationship that exists between these different trigonometric functions can be applied in order to find angles or unknown angles and distances. Now that we have introduced the concept of Pythagoras theorem and how we can be able to express different ratios for this relationship between the angles and the sides of a right triangle. Now, suppose I have a right triangle. We can just have a sample question or an example to try and illustrate this relationship. So I have a figure here. Just extend it. I have a figure here. And the two angles which are formed between the points A, B, in that the first angle is 19.9 degrees and the second one is 21.8 degrees, and the distance between A and B is 50 meters, and the distance between B, let's call this one point CD. The distance between B and C is x, which means it's unknown, and then the distance between C and D is y. So whenever given such a kind of a figure, we can use trigonometric ratios or the relationship that we have discussed which exists in order to find the distances or the ratios of the distances between A, B. Let's assume the distance is in meters, just remove that m. So we can find the distance between AC by using the trigonometric relationship that we've talked about. In that, using the concept of a SOHCAHTOA, bearing in mind that we have understood what it basically stands for, therefore we can say that the time, this is the adjacent opposite. Adjacent opposite. If we try to see the relationship between these three, the tan bears that relationship of those two specific sides. So therefore we can say that the tan of the given angle, which is 19.9, is equals opposite y over the adjacent. Now for this, the adjacent is going to be the point AC. For this angle 19.9, the adjacent is going to be AC to form a right triangle, as we said. So therefore it's going to be y over 50 plus x, bearing in mind that the distance is going to be in meters. So that's our first relationship. And then the second relationship we're going to have is tan 21.8 is equals, both of these are in degrees, is equals y over x. So given that for the two we have obtained a similar quantity that we can be able to solve for, therefore we can say the tan 19.9 is equals y over 50 plus x. And we're going to use the two relationships and try to find a common, maybe a common figure or maybe a common subject that we can be able to use to relate other questions. Therefore, we can just make y the subject of the formula. And for the first expression, we're going to have x into the tan of 21.8 degrees is equals the tan of 19.9 into 50 plus x. So this is a relationship that is going to exist between the two. So therefore from our tables we can be able to find the values of the respective tans that we have just written on the board. And we're going to have an expression that is going to appear appear as 50 plus x, 50 plus x, the tan of 19, the tan of 19.9 is going to be, let's have a reading from the table, it's going to be 0.3620. So basically I can just do a rearrangement for this, it to be appropriate. So 0.3620 into 50 plus x, which is y, is equivalent to x, the tan of 21.8, which is x into 0.4. So I hope these figures are going to be, we read them direct from the table. I hope that I've made a correct reading. For that we can confirm. But for this we are going to solve for x and find out that the value for x is going to be 476.3 meters. So therefore the distance that we had given for this, the distance for this figure that we had given, the relationship between, this is basically joining to that. So this was y, x, 21.8, 19.9, 50 meters from A to B, and then there was x, a distance that was x. So therefore we're going to see that the value for x is going to be 476 meters, and as well from that we can be able to find the value for y in doing a substitution in either of the equations that we have done. For instance, we're just going to write y is equals the tan of 19.9 into 50 plus x, and we have said that we can be able to find the value for this from our tables 3620, 50 plus x. So therefore, having found the value of x from this, we can be able to write it as 0.3620 into 50 plus 476.3. So therefore the value of y in this case is going to be 190.5 meters. So using the trigonometric functions that we talked about, we have been able to do a calculation and find out the distance, the known distance between the points B and X, which is of course this one X, and this point, perhaps just call this one D, XD, which is Y, which has given us 190.5. So basically this is how we're going to apply the trigonometric relationship in finding out the angles and the distances of our known values, or the ones that we have been given, by exploiting the relationship over the inverse and the basic ratios, trigonometric ratios, and the Pythagoras theorem from the right angles, as I've said. That we have understood one or two from this, and we're going to apply it appropriately in case we can place.